Okay, let's start at the beginning. They want the coefficient on the term with x7 in it. And this is not a binomial, it's a trinomial being expanded. And certainly I don't want to expand the whole thing. I just want to get the term with x7 in it, all right? So the way we suggest this is by simply just writing it as a binomial. And so as I do that, I want to point out the way I would do that, I would write it as, let's take a look. 1 plus, I'm going to rearrange those last two terms to be a little neater. X cubed minus 2x, and that whole thing raised to the 6th power. Now I got the binomial now. You know, this is the first term, that's the second term. So I do the expansion. And when you do the expansion, coefficients, and you can certainly use Pascal's triangle if you want, and you're going to get a bunch of coefficients to deal with. Let's talk about those coefficients. You'll get a 1, you get a 6, you get a 15, 20, 15, 6, and a 1, all right? So certainly we've done that many times before. And the next thing I want to do is talk about, the 1's nice because it's always going to be just 1, no matter what power it is, so it's always 1. But this second term, let me write that down for you, is really x cubed minus 2x. I'm going to factor that. I get x, and what do you get next? You get x squared minus 2. And then what do we do? Kind of go through the list. You know, 1 power of it, that would be this over here. The second power of it would be this one over here. 3rd power, 4th power, 5th power, 6th power. All right? Now, let's not lose sight of the goal here. Let me erase this business over here, kind of talk through that. We need to look at those terms now. And there are 7 terms, right? And I need to look at those terms that would produce an x7, all right? So I'm going to say this wouldn't do it. This one would not do it, all right? This last one would never do it. Let's kind of look through this. And the other ones, looking at, I got 1, 2, 3, 4 to look at now. And I'm going to say, let's take a look at that. Well, if you look at the next one, which is 15x squared, if you expand the binomial there, which is x squared minus 2, you get x4, x squared. You'd never get an x7, so this one's out of the question, all right? Let's look at that x5, by the way, and let's see if that would produce it. And let's see, 6x5. Well, with the expansion of a 5 there, you would get an x squared, which would give you an x7. So I'm going to say this guy is a successful character over here, all right? So I want to make sure we need to expand that guy, all right? Now, of course, I don't want to expand everything. I just want to get x7 out of it. Let's kind of look around, and I'm looking, and look at the 20x cubed. I would need an x, let's see, x4 there. Yeah, I'd get an x4 there. This looks good. Let's look at the 15x4. And I'm looking at the expansion of x squared minus 2 to the 4th power. And that's going to give me, like, you know, 8. That's 2 to the 4th power, and 6. No, that's not going to do it. This one gets crossed off. So there's only 2 success stories over here. This is a success one over here. That's the 20x cubed, x squared minus 2. And the other one's this one over here. It's the only 2 terms in that expansion that's going to give you an x to the 7. So we're going to look at it. And how do I look at it? Well, I expand it. So we're going to expand this one first. We got 20x cubed. And then what do I need on the inside? I would need an x4. All right? So we're going to look for the x4 over here. And how would I produce that? That would be produced by an x squared. And then you get minus 2. And this being raised to the 3rd power. So that's going to be a 1. What comes over here? Well, it's going to be 3, 2, or 1. Doesn't much matter. Now, let's take a look at that. What would that give us? Let's see. You get 3 times minus 2, which is minus 6, x4. Good. I got it. I got this one over here. What would that produce over here? Well, I hope you realize it produces, you know, a coefficient on the 7th degree term, which would be minus 120. All right? We got that part covered. Let's go to the next one. And start to erase this business over here. I'm kind of done with that. And let's talk about this guy over here. So we're expanding this over here. What do I need? I need an x squared. And there's only one way to get that. And let me just write that down. I'm going to get an x squared over here. That means I'm going to have the 1st power of it. And again, I'm expanding a binomial. And then you're going to have minus 2 to the 4th power. You're going to have a coefficient over here, binomial coefficient. And what's that going to be? Let's see. That's going to be 5. 5, 1. So you get, let's see what you get over there. I gotta be careful here, don't I? It's gonna be a 5, and you got this over here. That's gonna be 5. I'm just looking at the number now, and then you're gonna get, let's see, minus 2 to the 4th power is a positive number. 2 times 2 to the 4, 8, 16. That's gonna give me 80. Yeah, not bad. That's 80. So I see the 80x squared. I'm seeing that. And let's talk about the number now. This is the coefficient on the 7th degree term. So you're going to get 20 times minus 6, and you're going to get 6 times 80. And if you do that arithmetic, you'll get 360. All right. Let's talk about, if you're reading a book, the textbook, by the way, and you have an algebra textbook, and you're reading this, you're certainly reading about a multinomial expansion, all right? Which to me is a lot quicker to do it. You should learn about this. It's something that's going to come up later in mathematics where you expand things multinomially. And I'm just looking for x to the 7th. And how could I get that? Well, I could take 1 factor of this and 2 factors of that. And again, the expansion we're looking over, there's 3 terms in that expansion. Or I could take 4 factors of that and 1 factor of this. And I'm going to put a 1 over here. All right. So, the multiple expansion is really not bad. I mean, it almost looks like the binomial expansion, except the divisors are different. So, 6 factorial, 6 factorial, 3 factorial, 1 factorial, 2 factorial. Let's see, 1 factorial, 4 factorial, and 1 factorial. And if you compute those numbers, what are you going to get? Minus 120, no surprise there. And the other one's going to be 480. And no surprise there. It's that number over there. We're getting both of those numbers. When you have them together, what do you get? You get 360. All right? For those students that did the entire expansion to figure it out, what you do is the entire expansion, which to me, it just seems like a tremendous amount of work to do by hand, but there's nothing wrong with that. I mean, you could do it. And you get this really long polynomial. But they're only interested in x7. And what do you get over here? I see it right over there. So if you did the long expansion, which to me would be a lot of work, you will get that too. All right? Thank you so much for paying attention.